Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 8, Section 5, Quadratic Equations, Difference of Squares. Alright, so why? Computer graphics designers use a combination of art and mathematics skills to design images and videos. They use equations to form shapes and lines on computers. Factoring can help to determine the dimensions and shapes of the figures. Okay, so when you're doing difference of squares, okay, you factor the difference of squares. Now recall that in lesson 7-8, you learned about the product of the sum and difference of two quantities. This resulting product is referred to as the difference of two squares. So the factored form of the difference of squares is called the product of the sum and difference of the two quantities. Okay, so what this looks like is when you have a square minus b square, this is actually a plus b times a minus b. Or you can switch these. Remember, 2 times 3 is same as 3 times 2. So if we switch it, a minus b times a plus b. Okay, so what does that look like? So before, if you had a product like this, you can do FOIL, but in the previous lesson, you learned that instead of doing that, you can just say it's x squared minus the b squared. Now we're going backwards, so it's if you have x squared minus 25, and you know that the 25 is a square of a 5, then you can write that as x plus 5, x minus 5, or x minus 5 times x plus 5. So here you see that 64, you know that's the square root of 8, so you can say t plus 8, t minus 8, or t minus 8 times t plus 8. Okay, so here's some examples. If you have 16h squared minus 9a squared, you know that 16 is 4 squared. So you put all of that in the parentheses, 4h squared minus, you know 9 is 3 squared, so 3a goes into parentheses squared. Okay, so in fact this is the a and this is the b part. So 4h plus 3a, 4h minus 3a. So here you have 121, you know that's 11 squared. If you're not sure, then you can always put in the calculator the square root of 121, and I'll tell you that it's 11. Okay, so you have 11 plus 2b, and 11 minus 2b. Okay. All right, here you have 27g to the third minus 3g. Because you have the terms have a common factor, factor out the greatest common factor first. Okay, what do they have in common? They have 3g in common. So if you take out 3g, you have what's left, 9g squared minus 1. Okay, so if they do have a greatest common factor, do that first. And now let's work with this part. You have 3g squared minus 1, which is 3g in parentheses squared minus 1 squared. Again, so you can put that factored by doing 3g minus 1, 3g plus 1, and you have all three factors there. Okay, so here's your turn 1a and 1 through 1d. Factor each polynomial. Okay, so here again, I'm going to write it out for you. If you have a squared minus b squared, okay, you can factor this by saying this is a plus b times a minus b. Okay. So go ahead and pause the video right now and go ahead and on a separate sheet of paper do numbers 1a through 1d. And come back when you are done. Alright, welcome back. Let's go on to example 2. Apply a technique more than once. Alright, so what does that mean? When you have examples like b to the 4th power minus 16. Okay, b to the 4th is actually b squared squared again. And 16 is 4 squared. So now you have, think of this as a and that as b. So a plus b times a minus b. So b squared plus 4, b squared minus 4. Okay. Notice that the factor b squared minus 4, this is again, it's b squared minus 2 squared. So you can factor this one again, and this comes out to be b plus 2, b minus 2. So we factored it here once, and then we factored this b squared minus 4 again, because that was the square of a difference. Okay, so now we have completely factored, you have three different factors there. So again, 625 minus x to the fourth. Okay, if you want to do square root of 625, you'll find out it's 25. So you have 25 squared minus x squared squared. Okay, so you think of this as a and b. So a plus b, a minus b. So 25 plus x squared times 25 minus x squared. So again, if you look here, this is 5 squared minus x squared. Square of a difference, or difference of squares. So here you can do 5 squared and x squared. Okay, so this part becomes 5 minus x, 5 plus x. So you factor it twice. Okay, so here's your turns, number 2a through 2d. Go ahead and do those 4. Okay, if you need to factor it more than once, you can do that. Make sure you completely factor each term and come back when you're done. All right, welcome back. So sometimes more than one factoring techniques needs to be applied to ensure that a polynomial is factored completely. Okay, so example 3. You have 5x to the 5th power minus 45x. Okay, here is an example where you factor out the greatest common factor. So what do they have in common? They have 5x in common. So factor out 5x and you're left with x to the 4th power minus 9. Now you have, this is squared and this is a square. So you can rewrite that, x squared squared minus 3 squared. Now you have, again, this is the a part, this is the b part. So a minus b, a plus b. So x squared minus 3, x squared plus 3. And you still have the 5x out there that's been factored. Okay? Notice that the factor x squared minus 3, this is not a difference of square. So this is your final answer. Okay, let's move on to example B. 7x cubed plus 21x squared minus 7x minus 21. Wow, that's a long expression. So what are you going to do? If you notice, it's 7, 21, 7, 21. They all have 7 in common. So factor out the 7, and you're left with x cubed plus 3x squared minus x minus 3. Okay, so let's work with what's inside here. You have x cubed plus 3x squared minus x plus 3. Okay, so we factored out the negative 1 here, and now use x plus 3 instead of minus 3. All right, so here you have, again, you can factor out the x squared. There's another greatest common factor here. So if you take out x squared, you have x plus 3 left. And here you took out the negative 1. Now you have x plus 3 and x plus 3 in common. So I'm going to factor out that. So x plus 3 comes out factored. What do you have left is x squared minus 1. So x squared minus 1. Okay. Now you have x squared minus 1, difference of a square. This can be factored out to x plus 1, x minus 1. So now you have your completely factored answer right here. Okay. So you just need to keep on factoring until you can't factor anymore. Okay, so here's your term numbers 3a through 3d. Go ahead and factor all those terms out. You need to just keep in mind you have to keep on factoring until you cannot factor anymore. Oops. All right. Solve equations by factoring. After factoring, you can apply the zero product property to an equation that is written as a product of factors set equal to 0. Okay, so if you have equation like this, which is a value of x when y is 0. So if they're asking you if x squared minus 9 over 16, if that equals 0, okay, what is x? Alright, so replace the y with 0. Okay, so we did that and solve. Alright, so here we have x squared. You know 9 is square of 3 and 16 is square of 4. So you have difference of squares here. So x plus 3 over 4, x minus 3 over 4. That means, if you remember from the previous lesson, we have zero product property. If you have two products, if you're multiplying two things and it equals 0, it can be this can either be 0 or this can be 0. So x plus 3 over 4 is 0, or x minus 3 over 4 is 0. which means your answer could be negative 3/4 or 3/4. So the correct answer is 3/4. Okay. Go ahead and try number 4. So here it's not equal to 0, but you can definitely make it look equal to 0 by doing 18x cubed. Subtract the 50x, and that equals 0. Okay. So factor out this portion, and see which numbers will equal 0. And if you're done with that, that's your last problem for today's homework. Today was a short lesson, so yay. Put your name on that homework and claim it and hand it in for credit tomorrow when you get to school. Thanks for watching.